All right, the next skill we're going to cover is finding the inverse of functions, reviewing a little bit of function notation, and also learning how to compose functions to prove inverses. Okay, so all of that's about to happen with this example. So quick review of function notation. All that function notation means is that we are going to take whatever input is being told to us in the parentheses and use that instead of my variable. So right now, I have x and x, right? So what would happen if I replaced it with f of 3, right? F of 3 means take that x and replace any x that you see inside of here with the value 3. Our input is going to be 3, okay? So I'm going to write this exactly the way it is, but instead of that x, I'm going to put the 3 plus 3, and then I'm going to simplify. I have cubed root of 12 plus 3, which gives me the cubed root of 15. That does not break down, so that would be my final answer. What that means is on the graph of my function, if I looked where x equals 3 is located, my y value there, or my output, would be cubed root of 15. So I could write this as a point then. I would have 3 and the cubed root of 15, if I was graphing it. If my problem simply asks me to find f of 3, all that I need to write as my answer is this simplified form of my output, okay? So now let's use this same equation to review finding inverses. The relationship between inverse functions is always the same, and here is the relationship. My inverses always switch their x and y, okay? Or their input and their output. Okay? So what that means is that on a table or a graph or an equation, you are always going to take your input and your output and switch them. Okay? So for example, if f of x had a point at -2, 7, the inverse of x, which we show using this little -1, would be switch the input and the output. 7, -2. Is that on the screen? There we go. So it would be 7, -2. Okay, so we're just switching the x and the y value. That's what you do with a point. You could do that pulling a point off of a graph and doing that, okay? Or we can do it in an equation. So for this equation, my output is f of x, my input is x. Okay? A lot of times you'll see people change the output to a y just because it looks more algebraically simple. Okay? But they're the same thing. Remember, f of x means output, but y also means output. So what I'm going to do to find the inverse is I'm going to take my x and my y and switch them. Okay? I'm switching the position of them. I'm not changing anything else. So my y is simply going to become an x, and my x is going to become a y. Okay? Notice that the 4 doesn't move, the +3 doesn't move. The only thing that's happening is that the y is turning into an x, and the x is turning into a y. From there, I want to, using my new vocabulary, get y in terms of x, or get y by itself. Okay? So I want to undo everything that's happening to y. The opposite of cubed rooting something is cubing, which I have to do to both sides. So I have x cubed equals. The cubed rooting and cubing are inverse operations of each other, so they undo each other, it goes away, and I'm left with 4y plus 3. To get y by itself, now I need to subtract the 3, so I have x cubed minus 3 equals 4y, and then to get y by itself, I would divide by 4. Now my y is going to be by itself. Instead of calling it y, I know that I didn't just find any equation. I want to label it specifically. And I know that what I found is the inverse of f of x. So we're going to write that in our inverse notation with the little -1 is equal to x cubed minus 3 over 4. This is the inverse function of my original. All right, we're going to use these same equations that we just found because we know that they are inverses. We did that work ourselves, right? We're going to do something special that is called composition of functions, and we are going to see if these are inverses, okay? So really quickly, going back to evaluating functions, we're going to talk about composing, okay? So when I had f of x equals the cubed root of 4x plus 3, and I did f of 3, right? I just took my 3 and plugged it in, or substituted my x with that 3, right? That's what evaluating means. We can do that with much more complicated things. It doesn't just have to be a number. It could be a symbol, or what we're going to start seeing more and more frequently is we can insert a whole new equation in place of this variable here. Here's what that would look like. Okay? If I was doing f of, we'll start with one that's simple, f of x plus 2, I would take this whole x plus 2 and put it inside where my variable used to be, where my x used to be. So I would have the cubed root of 4, being careful to plug that in using parentheses so that we don't forget about our distribution that's going to be necessary. Now I can take this 4 and distribute it. I would have the cubed root of 4x plus 8 plus 3, which would give me plus 11. Okay, and I can't go any further than that. I've got my x, I can't simplify. Okay, so that's what it looks like to plug in an equation. Now we're going to talk about what happens in particular when you plug in something that is an inverse. We always get the same answer, and we're going to find out what that is. We are going to compose f of x and my inverse and see what happens. What this means, we say this as f of f inverse of x. Okay, f of f inverse of x. So we've got multiple layers happening. What this means is I'm going to take my x value from f of x and I'm going to replace it with this function. But instead of plugging in this notation, I actually want to use this because I want my x, right? I want it in terms of x. So I'm going to start with my one that's on the outside. Always start on the outside when you're composing functions. So f of x, my original, I'm going to start writing it, and when I get to x, I'm going to stop and replace that x with this right here. Okay? So I'm going to have 4. I hit my x. Instead of that, I'm going to write this. So I have x cubed minus 3 over 4. And then I need to continue any pieces of this that I didn't use. So I had the 4, I replaced the x, I have the plus 3. Now I'm going to simplify it, and we're going to see what happens. Here, I could technically distribute this 4, right? But what's going to be faster for me if I recognize that 4 divided by 4 is going to be 1. Those can cancel out. So if I divide those out to be 4, I'm left with just x cubed minus 3, and then this plus 3. Okay? I can keep going there. I can recognize that the negative 3 and the positive 3 will become 0. So I have the cubed root of x cubed. And then the cubed root of x cubed, those are also inverses of each other. They're inverse operations. So x cubed and cubed will cancel each other out, and I will be left with just x. Okay? This is a special type of answer because when I get x, just x, as my final answer, what that means is that the functions that I composed must be inverses of each other. Okay? It has to be inverses. So anytime that you get x, just x, after you compose, that means that those two functions that you composed are inverses. Last example we're going to talk about with composition and proving inverses is this one here. So what you might see is asking are f of x and g of x inverses. The way I test that is to plug one of them into the other one. It does not matter which one you plug in, they should both work. Okay, so I'm going to say f of g of x, meaning that I'm going to take my g of x and I'm going to substitute it in for my variable in f of x. Okay, so you always start with the outside, you're plugging in whatever's on the inside, just like we plugged in that 3 earlier in other examples. Okay, so f of g of x. The other way you might see this written is f of g of x. Okay, it looks like fog, but it says f of g of x, which is how we read this one as well. Okay, so just a heads up, if you see this notation, it means the same thing. Okay, now I'm going to actually figure this out, and remember, if they are inverses, I should get an answer of just x, just one x. Okay, so here I'm going to start by writing my f of x. I immediately hit my x, so instead of this x, I'm going to replace it with this whole g of x expression. So I have square root of x plus 5 over 3 squared, from here again, going back up here, minus the 3, over that original 5. Okay, so everything about this one is represented in here. The only difference is that the x has been replaced with my g of x function. Now I'm going to simplify. This squared here is going to apply to the numerator and the denominator. So the squared on the numerator will cancel these out, right, because those are inverses. And I'm left with x plus 5 over, I also need to square my denominator, so that would be 9. The minus 3 goes up here over 5. Now I can continue to simplify by getting a common denominator. So this would be, I would need it to multiply by 9 over 9. So I would have, you still see this? Yes. So I would have x plus 5 over 9 minus 27 over 9. And instead of leaving this as a nested fraction, is what we call this, a fraction within a fraction, I'm actually going to write it as divided by 5. Now I have x, the 5 minus 27 becomes minus 22 over 9. Dividing by 5 is the same as multiplying by 1/5, multiplying by its reciprocal. So now I have x minus 22 over 45. I can't simplify this, so this is what f of g of x equals. It does not equal x, which means that f of x and g of x cannot be inverses.